All right, welcome to the AP Calc Unit 1 review. Before you get started with this, let me just say that it is not worth moving into this portion unless you have already gone through, made sure that everything has been done for all of the individual lessons. Because the first thing that I'm going to start talking about is the whole unit, looking at it kind of as a sequence. And if you have not gotten all of those parts of the sequence, and you can't go back and look in your notes and pull up a definition at will, then it's not going to be worthwhile. So if you're not at that point yet, go ahead and pause, go back through, even if you got to start at 1.01. Look, it's going to be more beneficial that you start there, where we're actually spending a good amount of time defining, creating a visual example for our definitions, so on and so forth, than trying to hit this review without the proper background. So the first thing I want to do is take a glance at the overall scope and flow of the first unit. That way you sort of can compartmentalize which pieces you want to study at what times and how you want to break them up, so on and so forth. Remember, we began with this motivating example of trying to find the slope at a given point. And that actually motivated us towards wanting to come up with the limit. And so it would be very helpful to actually go back and remember and take a look at this motivating example again. Because not only is it a motivating example for our discovery of the limit, and was a motivating example for the discovery of the limit when it was discovered, but is a motivating example sort of for everything that we're going to do for the first unit. And certainly this unit culminates with looking at that situation again. So it would be very worthwhile. So that led us to begin with the discovery of the limit. And taking the limit as the x value of a function or the input of a function approached a certain value. And this became very helpful for taking a look at how to describe a function which is undefined at a given point, but that doesn't really tell you what you want to know about the function at that given point. And so the limit allows us to do that. And so we looked at all kinds of limits, limits to infinity, how to evaluate limits, different ways of defining things in terms of limits as far as asymptotes, and developed some strategies for solving and evaluating limits. We then had a quiz on this, so I'm not going to spend really any time at all rehashing limits. If you want to take a look at lesson 1.06, that in fact was an entire review lesson on limits in which I talk about strategies for how to attack limit problems. And what I say in that video is that you should come up with a strategy yourself, having practiced some limit problems, and refine it as you go along for yourself, because my strategy may not be how you want to think about it. Certainly it works for me and will work for you if you want to apply it, but it should be something that you really understand and buy into. So that Unit 1.06 video is a good place to go once you've tackled limits, reviewed it, and feel like you want to test your ability there. I would also then take a look at your quiz. Your quiz would be your limits quiz would be a very good thing to take a look at and redo to test your ability on limits. So that limits review 1.06 along with your quiz will be a good test of your skill with limits. With that being said, a part of all of these topics that we talk about, a really important thing and something that you must have is definitions and theorems memorized. Now, I am, as you know, not a fan of memorization in the sense that you shouldn't sit there trying to memorize the words of a theorem or the words of a definition. What you should spend your time with is learning to the point where you can recall it and understand it at will. The definitions of certain things, certainly the definition of a two-sided limit, is something that you should have immediately at recall and should be able to understand at any point that you want. And the best way to do that, in my opinion, is to be able to visualize it. And so you'll notice with all these definitions and theorems, there is a visual, usually a graphical representation that goes along with it. And so even more than just the words in the definition, it would be very worthwhile to understand the visual representation. That will actually make it easier for you to recall and apply the definitions and theorems. Remember, there are going to be questions that are just going, and on the AP test as well, that are simply going to test your ability to remember the definition, right? If you can't remember the definition of a two-sided limit, when a question gives you both one-sided limits and asks you what you conclude from it, you're going to be really lost. So make sure you spend time with those. I will say this, the squeeze theorem, important to know, just in general because it is very useful. But again, there's something that memorizing the words of it will take you way too long and not be worthwhile, whereas really understanding why it works, and particularly graphically, will be much more helpful. Alright, so after limits, we then started using limits to define some things about functions. And the first thing that we talked about was continuity. And we used limits to define continuity precisely. We had talked about how continuity is when you are drawing a curve and you can draw it without lifting your pencil off the paper. And what we did then is define what that actually means mathematically. If you can't bring your pencil off the paper, what does that mean? How do you guarantee that you won't have to bring your pencil off the paper when you're drawing it? And we talked about how you can define that in terms of the limit existing and the limit being equal to the value of the function at that point actually guarantees that your pencil won't ever have to come off the paper when you're drawing it. We defined what a continuous function is. We listed a ton of continuous functions that are always going to be continuous on their domain. And we practiced evaluating whether or not a function is continuous at a given point, particularly with piecewise functions. Again, I cannot stress enough how important definitions and theorems will be. If you don't have the definition of continuity down cold, then when an easy question about whether something is continuous pops up, you're going to be grasping for air. And that's not going to be good, because that's going to be a question that you want to just spend maybe 30 seconds on. Within continuity, of course, was the intermediate value theorem. This is one of the most helpful theorems, but also just such a common sense theorem. And so it would be really worthwhile understanding that theorem, not necessarily stating it word for word over and over again, but rather first understanding the visual representation, and then once you really understand that, working on refining the verbiage of it so that you have that down cold. After continuity, we finally came to sort of a culminating piece in the unit which reflected back on the motivating example by looking at instantaneous rate of change. And with instantaneous rate of change, or the slope of a curve at any given point, we were able to talk about defining different lines. More importantly, the most important ones that we're talking about are a tangent and a normal line, of course the secant line as well. And those are things that we spent a good amount of the past week doing. Rate of change. Okay, here again, cannot stress enough how important understanding and knowing the definitions and theorems are to your success. If you understand the definition of instantaneous rate of change, and again, the visual representation is so important, that will help you understand it and memorize it and learn it more quickly, then you're going to be in really good shape. There were some also fairly tricky problems involved in instantaneous rate of change. I'm going to put also here tangent and normal lines. And those are some really good problems to test your overall understanding of the unit. So for limits, we covered that pretty well. What I want to encourage you to do is to come up with, and I also kind of did this for continuity as well, to come up with a protocol. When you see a question that deals with continuity, how are you going to attack it? When you see a question that deals with instantaneous rate of change or finding a tangent or a normal line to a curve, how are you going to attack it? What are the steps that you're going to take, or at least in general, what is it that you're going to want to find that is going to help you solve that problem? That's not something that I'm necessarily going to talk about in this video, but in the solutions video that I do, I might touch on briefly, or if you have any really specific questions or want to run your protocol by me, certainly feel free to email me at any time. Okay, now that we've talked about that overall scope, you can sort of go off and review any pieces that you want. I'm now going to put some questions for review. These are not in any particular order. They're also not particularly indicative of what will be on the test. Anything from the unit, any concept could be on there. So you should be prepared for everything. These are just additional practice problems to the many that we've already done that would be helpful and pertinent to your practice. So I'm just putting these up again. These are the questions that we did during 1.12 in class. And in particular, there were some very interesting questions here. Number 2 and number 3 were great questions that really pushed your thinking. I remember Michael spending probably 2.5 hours over 2 different days on number 2, and that's why I haven't erased his work from the board. But it will be erased in time for the test, don't worry. Number 4 was more of a kind of group exploration, so if there's one that you're going to skip from this page, it would probably be number 4, although it is interesting to look at and could be helpful. And number 5 is also a great question. All right, here are some more. These are kind of broken up by category. I'm going to, for those of you that don't have a book, I'm going to in the future clips of this video actually put these questions up. I'm going to write them out by hand. But for those of you that just want to go ahead and get started and have a book, here they are. Limits and continuity, here are 7, 8 questions that would be good to look at. But look, you have plenty of limits and continuity questions to take a look at from the videos, particularly for limits with the quiz that you've already done. Instantaneous rate of change also should be fresh in your mind, but here are 8 more questions to really push your thinking there. And then that we're going to get at least one real meaty AP prep free response question, and so I've provided you with 3 to take a look at that will push your thinking and resemble that one that we looked at on the quiz, that last question on the quiz. So this is a good place to start. If I come across anything else that I think would be really good for you, I will obviously put it up in a video. A word of advice, hopefully you're looking at this on Friday night or Saturday morning. I'm going to make myself available via email. If you have literally any question at all, it would be most beneficial for you and me if you emailed me on Saturday. That's the day that I plan on getting a lot of work done. You know what I'll be doing on Sunday, but I will take time away from whatever I'm doing to answer your question immediately. You all should have my email from our correspondences this summer regarding the Summer Academy. That would be the best email to reach me at. I will get it the quickest. If you email me at the school email, I will check that as well, but you are privy to that other email, so that would be helpful if you want to get your question answered quickly. If enough people ask about a certain question, or even if you just have a question that I think is best explained via video, I may make you a quick couple-minute video and upload it on the spot for you. So make sure you study this weekend. Ask me any questions this weekend. Monday morning will not be the time to ask questions. Like I said, might not be there Monday morning until maybe 7:15. So good luck, and please let me know if there's anything that you need.